All right, today we're going to go over converting scientific notation. So scientific notation is a way to represent a number that's either really big or really small. And so the correct scientific notation includes the first number, which is a number between 1.0 and 9.9. Essentially what it is where the ones place is always represented. So in this case, there's always a number in the ones place. So the first number always has a number in the ones place, and then it might have some decimal places after. These are non-examples over here because, as you can see here, there's a 0 in the ones place, so that won't work. And here, there is a ones place, but there also is a tens place. So you cannot have anything before the ones place. It's the one place and then a decimal. However many decimal places you have after is fine. So now we're going to learn how to convert significant figures, or sorry, scientific notation into standard form. Standard form is just your normal number. So there's two parts. The first part is the actual number itself. So here we have 2.05. And then this part, the exponent here, let me just point to this particular. The exponent tells us how many times to move the decimal. And so the fact that I have a positive 2 tells me I want to make this number bigger by moving the decimal point 2 times. And to make the number bigger, I need to move it to the right, right? So I'll move it like this. So this would give me 205. Now, if I have a negative exponent like I do here, I'll take that same number, but now I'm going to make the number, smaller. And so to make it smaller, and the reason why I'm making it smaller is because I have a negative exponent. And so therefore, I'll move the decimal 2 places to the left. So here, here. What that does is I need to add a 0, so it'd be 0.0205. Once again, I moved it over 2 places to the left. I moved them left because I had a negative exponent. I moved it 2 times because the exponent was to a 2. Here I have 9 times 10 to the 5th. So the exponent is positive, so I'm going to make the number bigger. So I'll take 9, the decimal's here, and I'll move it 5 times. 2, 3, 4, 5. 1, 2, 3, 4, 5. So my answer is 900,000. Notice also that I have 1 sig fig here, so this has 1 sig fig, and my answer should have 1 sig fig, or whatever I convert it to should have 1 sig fig. They should match. So obviously I won't be able to put a decimal there because that'll change my number of significant figures. Here, 8.88 times 10 to the negative 3, so I'm going to make this number smaller. So I'm going to move the decimal in a smaller direction, which is to the left. 1, 2, 3. Decimal goes here. Fill it in. So you got 0.0088. Notice I started with 2 sig figs here, and I have 2 sig figs here. Okay. All right, so that tends to be the easier way. The more difficult way is to go back. So if I give you standard form, can you convert back to scientific notation? You almost have to think of this as backwards. So the first thing I'm going to do is pick a number. So I have 1, 2, 3, 4, 5, 6. My decimal is here. Oops. So I'll have to move this 1, 2, 3, 4, 5. So my new number is 1.23456. Remember, I need a number in the ones place and then everything after, right? So this is the corresponding number. However, I move the decimal point. Now the way I do it is the numbers comparatively, like if I compare this number with this number is much bigger, right? And so therefore my exponent is going to be positive. So if the number I started with is bigger than what I ended up with, my exponent is positive. And I moved it 5 times. So the 5 tells me how many times I moved the decimal. The fact that it's positive tells me that my original number was bigger than the number I have here. And I always suggest that you check. So 1.23456. So if you move it 5 places to the right, I'm making the number bigger, right? This will give me 1, 2, 3, 4, 5, 6. And that checks back here. That seems to help, and we can do this check mentally. If I put a negative here, notice my decimal would go the other way, and the number would get a lot smaller. Okay, so let's do the next one. So the next one is 0.0158. So I'm going to have to now change this into a number that is between 1 and 9.9. So I'm going to move this decimal 2 times. So it's now 1.58 times 10, and then I moved it 2 times. Now I have to go back and figure out, oh, is it going to be a -2 or +2? So I notice that this number, or this number, is smaller than this number. The fact that it's smaller makes it negative. I check my answer, 1.58. I want to move it. I have a negative exponent, so I'm going to move it this way. And this was the original number. Okay. Same thing here. The decimal, I'm going to move 1, 2, 3, 4. 1.001 times 10 to the. Now this number was bigger than the new number, so I'm going to use a positive exponent, and it'll be 1, 2, 3, 4, so a positive 4. I want you to notice a couple things too, and I chose this for a reason. What I want you to notice also is this has 4 sig figs, 1, 2, 3, 4, and therefore this has to have 4 as well here. So notice I did not include that 0. So this 0 would have added another significant figure. So we don't not include that 0. If I check, this would give me 1, 0, 0, 1, 0. I moved it 1, 2, 3, 4 times, so I can check that. The answer here will be 1.801. Don't include the 0. And so I moved it 1, 2, 3. Oh, I didn't want to do that. I moved it 1, 2, right? And that got me there. And so I moved it 2 times. This number is smaller than this number, so I moved it negatively. And then I can always check. The answer should be 0.01801. Now, the one thing I want you to check is I need to include the 0 here, because I have 1, 2, 3, 4, 5 sig figs, so I need a 5th sig fig here. 1, 2, 3, 4, 5. In this case, the 0 is necessary, right? So then I'll know to add the 0 here. All right, 21.02 times 10 to the second. Now you'll notice that this is incorrect scientific notation, so I need to convert it into correct scientific notation. And so the way I turn it is, it'll be, I'll have to move it over 1, right? Okay, so now it becomes 2.102 times 10. Now I originally had 10 to the second. Now I moved it. 21.02 is a bigger number than 2.102, right? So I added another, or I moved it over once, but I moved it in a positive way, so it should be 2.102 times 10 to the third. Okay. In this one, this is not correct scientific notation. I didn't move it 2 places here. So 5 times 10 to the second, and then I have to do something with this other 2. So I'm going to put it here. Now, since this number was smaller than this number, I actually, so I'm going to put a negative, right? And so this will actually become equal to 5 times 10 to the 0 power. Okay. All right, and there's your homework. This is pretty good. So what it is you convert it, and it tells you if it's right. So here I need 7.8, right? And then I did 1, 2, 3, 4. So the exponent will be 4, a positive 4 because it's a bigger number. Or this was initially a bigger number. And so check your answer, and then you go ahead and do a new problem. Okay?